Hey, today's lesson is going to be a little bit radical. Radical. Today we're going to do operations with radical expressions. Our objective today is to simplify sums and differences of radical expressions. The next lesson will be on products and quotients, but let's deal with the sums and differences. So you can use the distributive property to simplify sums or differences of radical expressions by combining like radicals. So it's combining like terms. It's a very similar concept, but you're combining like radicals, like 3 times square root of 5 and 7 times the square root of 5. They do have the same radicand, so they are like radicals. Unlike radicals such as 4 times the square root of 3 and negative 2 times the square root of 2, those are different radicands, so we would not be able to combine those when you're adding or subtracting. Like for instance, combining like radicals in problem 1, we have 6 times the square root of 11 plus 9 times the square root of 11, and I notice that they both have the same radicand, so I can look at this as 6 plus 9 times the square root of 11, which is equal to 15 times the square root of 11. I can also do that when I'm working with the difference. Like for instance, the square root of 3 minus 5 times the square root of 3. I notice that they both have the same radicands, so I can combine like radicands. So for this one, my coefficient is 1, so I can do 1 minus 5 times the square root of 3. And that equals negative 4 times the square root of 3. And that's one detail to keep in mind. If there's no number there, it represents a 1 is represented there, because that's 1 times the square root of 3. Why don't you press pause and try it out on these ones? How'd you do? Now for 1a, notice I simplified it all the way down to negative square root of 2. The second one is 7 times the square root of 5, with square root of 5 being the common radicand, combining like terms. You might need to simplify a radical expression first to determine if they can be added or subtracted by combining like radicals. So in order to do that, like for instance, what is the simplified form of 5 times the square root of 3 minus square root of 12? I can take square root of 12 and I can factor that into 4 times 3, which equals, I'm looking for that perfect square. Square root of 4 is 2, and I'm left with square root of 3, so my problem has changed to 5 times the square root of 3 minus 2 times the square root of 3. I have my common radicand of 3, and now I need to deal with the 5 minus 2. And when I simplify 5 minus 2, I end up with 3 times the square root of 3. All right, why don't you try it on the got it? For A, B, and C, again, you might have to factor out your radical just to see if you can find a common radicand. Press pause. Pause, pause, pause. Pause. You didn't press pause yet. Press pause. I dare you. All right, for the first one, I needed to factor out the square root of 28 to get my 4 and 7, factoring out the 4. So I was able to have the common radicand of 7, square root of 7. For B, I had to factor out the 32 and the 18, both looking for a common radicand, which I did, which is square root of 2. And by doing that, I was able to combine like terms, which allowed me to subtract them, ending up with 8 times the square root of 2. When simplifying a product like this one, looks like we are going to do a little bit of distributing, so we are going to do some multiplying. Now this one's a little interesting because when you're simplifying the product like this guy, square root of 10 times parentheses square root of 6 plus 3, you're going to be utilizing the distributive property to multiply that out. If both factors in the product have 2 terms, then you're going to use foiling. So you're either going to distribute, or if they have 2 terms, both of them do, then you're going to use FOIL to distribute the entire process. So like for instance on A, I'm going to distribute square root of 10 times the square root of 6. I am going to, you probably won't write it all out like this much, but I'm going to, just so you can continue to see what's going on, and that is 3 times the square root of 10. And this ends up being 60 plus 3 times the square root of 10. Now in 60, I can factor out a 4 and a 15. And when I factor out, because I'm trying to simplify this completely, so I can see in here there's a 4 and 15, and I can factor out the 4, so it ends up being 2 times the square root of 15 plus, I can't factor anything out of the 10, so I need to leave that alone. And my 15, can't factor that out, completely prime. Can't factor out the 10, there's no common factors in there. And actually, same with the 15. What I'm looking for is I'm looking for perfect squares, and I can't. So actually, this is my answer. This is simplified. I cannot do any more with that. So sometimes your answers don't end up all nice and done and finished. Sometimes they do end up like this, which is fine. Let's look at B. This one, I have 1, 2, and I have 1, 2. So I am going to have to do some foiling on this guy. All right. So this is going to look big. You're probably going to use less steps. I just want you to see all the pieces to it. So I'm going to FOIL it out. So I have square root of 6 times square root of 6 plus O, which is the outside, square root of 6 times square root of 3 inside, which is going to be minus 2 times the square root of 3 times the square root of 6 outside. Actually, my last one with the FOIL is going to be minus 2 times the square root of 3 times square root of 3. Now let me simplify these pieces. So I end up with square root of 36. And some of you might see already early that square root of 6 times square root of 6 simplifies out to 6. You might see that really quickly and right away, which is fantastic. I'm continuing to simplify here. I see square root of 3 times square root of 6 ends up with 2 times the square root of 18. I end up with 2 and square root of 3 times square root of 3, which is going to be 9, but some of you will see right away that's actually going to be the 3. Square root of 36, we end up with a 6 plus square root of 18. I'm going to leave that alone. Can't really find any perfect squares. 4. No, 4 doesn't work. All right, I have to leave that one alone. 2 times 18. That's going to stay. And this one does factor out. The 9 becomes 3, so 2 times 2, this becomes 6. Looks like I'm running a little more room here. Now I'm going to look at these guys. I have a common term here, so I've got 6 plus. I can pull these together. So it's going to actually be negative. I'm going to look at it as subtraction. 2, and then actually, let's look at this for a second. Before we do this, there's a common one, there's a common. Remember, there's a 1 here. So I'm going to look at this as plus, and I've got 1 minus 2 times the square root of 18 minus 6. Okay, a little more room. Still working here. Did you notice this? This 6 and this 6? They end up canceling out, so those are gone. I'm going to continue with my middle piece here, 1 minus 2, so I end up with negative 1 times the square root of 18. And you know what? There is a perfect square in this. I see there's like a 9. There's a 9 and a 2, so I can equal negative 9 times 2, and that's going to factor a 3 out. So I end up with negative 3 times the square root of 2. Ends up being my final answer. And some of you might end up seeing some of these things early, like up in here where square root of 6 times square root of 6, you want to start identifying and recognizing that early on as that being just 6. You can recognize perfect squares early, like up here where we have the 18 and the 18. You can factor those out and see the 2 early. You can sure do that. It's all about simplifying. All right, for the got it, you've got 3 here. Why don't you go ahead and press pause, work them all out, and then come on back. Looks like for this guy, you're going to distribute. We've got a perfect square here, so you've got probably going to do some foiling and some foiling on this guy. All right, press pause and work it out. This might use a few lines of paper. All right, let's take a look. For the A term here, or problem A, 3A, that one actually was pretty quick, just distributing that out, factoring out the 12, and I found out that there's no terms to combine, so 2 times the square root of 3 plus 5 times the square root of 2 is my simplified answer. Because again, the main thing we're looking for is the simplified form, and sometimes you cannot combine everything. When I look at the second one, because it's squared, I have to FOIL this out. Originally, I see my square root of 11 is in both of them, so I can combine my minus 2 and my minus 2 together. I started recognizing earlier that square root of 11 times square root of 11 is just going to give me 11, so I went right to that. It's a pattern that's playing all the way through. Did my combining like terms and end up with 15 minus 4 times the square root of 11. Now the last one was kind of a big boy. That one definitely had some girth to it, and I had to FOIL that out completely. I wrote this out so we can see the whole thing. When I did this, some things I noticed was right here, square root of 6 times square root of 6 is just going to give me 6. That I knew. Square root of 3 times the square root of 3 is going to give me 3, so I was able to jump right to that. Anything else that I was noticing that I had to keep an eye on? I had to combine some terms early on. I noticed when I got down to the green here that I had like radicands of a square root of 2 and a square root of 2, so I was able to pull those together as my middle terms kept simplifying down to negative 6. So simplified form of this is negative 6 times the square root of 2 minus 6. All right, a lot of details, a lot of things to keep track of. All right, well, I don't know what you're going to do, but I am going to put on a pair of roller skates and ride around the city bus for the rest of the day.